Hey, hey, looks like we're online again. Good. Yeah, so day 10. We hit double digits. That's kind of exciting. Um, yeah, I'm all set, ready to go. I think I really enjoyed yesterday's challenge. If you haven't seen it yet, or if you haven't tried it yet, it's really worth doing. It's a little bit tricky, but I think it really captures the the quintessence of, is that even a word? Of these challenges. Anyway, looks like day 10 is ready, so let's get going. Um, cool, let's start with this. What do we have? Oh, it looks interesting. You asked the submarine, syntax scoring. You asked the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error in navigation subsystem on line all of them. All of them? The damage is worse than you thought. You bring up a copy of the navigation subsystem, your input. Let's just take a quick look at what that looks like. Um, okay, is that one line or is that one line? Uh, no, it's not. No, they're separate lines. Okay. The navigation subsystem syntax is made up of several lines containing chunks. There are one or more chunks on each line, and chunks contain zero or more other chunks. Adjacent chunks are not separated by any delimiter. If any chunks stop, the next chunk, if any, can start immediately. Every chunk must open and close with one of four legal pairings. So they have to just match each other. Cool. So two parens is a legal chunk that contains no other chunks, as is two square brackets. More complex but valid chunks include paren square bracket, curly, parens, 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 close curly, and so on. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line is one where a chunk closes with the wrong character. That is, where the characters it opens and closes do not form one of the four legal pairs above. For example, these are corrupted chunks because open and close don't match. Some lines aren't corrupted, just incomplete. You can ignore these lines for now. The remaining 5 lines are corrupted, so we're looking for just the corrupted lines. Stop at the first incorrect closing character on each corrupted line. Did you know that the syntax checkers actually have contests to see who can get the highest score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. In the above example, are these all prime numbers? No, they're not. That's divisible by 3. In the above example, in legal, closed parens was found twice, and so on. So the total syntax score is you add them up for that many points. Find the first illegal character in each corrupted line. So we need to find all the corrupted lines. Corrupted lines are lines that have an invalid closing character. So this feels like a perfect problem for a stack. Every time you have, I'm just going to print out one line so I can take a look at it. So every time we have an open character, we push it onto the stack. Every time we find a closed character, we check the top of the stack and check that it's the matching one. If it's not the matching one, we score that line. If we reach the end, then it's an incomplete line, but it's not corrupted. Okay, that feels quite straightforward. So we need a stack. So I'm just going to call, the stack is just going to be a slice of runes. So for each data line, so we have stack, and then we switch C for character, and then we look at each character in the line. If we switch it, it's just a little neater. If it is a open parens or an open square bracket or open curlies or open angle bracket, we do something. Otherwise, if it's the other set, we do something else. So we also need something to keep track of whether or not it's corrupted. So on every open, all we do is we push that character onto the stack. So stack equals append stack, the character, easy. Now on close, we need to check that the top, okay, so let's pop it off the stack. Len stack -1, that's the final character on the stack. A final value on the stack. And we can reset the stack now already. And that should give us, that will pop the final character off the stack. Now we have to check that it's the matching pair, right? If, cool, if C is open and pop is close, or the other ones, just making sure that they are the matching pair, then we are good to go and we continue. Otherwise, we have found something that is a mismatched bracket, and we need to set corrupted is true. At the end of this, we will break. Does break my switch? I think it does. So I'll call this loop. So we'll break loop. We also need to add to the score, don't we? We could, what we could do is we could do this. Make that a rune. And then set corrupted to the character. If corrupted, switch corrupted. If it's, what's the corrupted character? We want the closing version, right? If it's the closing this, then, okay, we need score is 0, score plus equals 3. If we have a closing square bracket, score plus equals 57. If we have a closing curly bracket, score plus equals 1197. I'm just reading these values off the description, of course. Yeah, in Go, you don't need a break. And default, well, default, we don't do anything. Yeah, in Go, there's no fall through. The score, what do we have? 0. Great. Let's see. Let's see. We can print the stack on each line just to kind of see where we are. These runes are really annoying. They don't print as not as letters. Am I not popping them off properly? I feel like I am. I have this run the wrong way. I have this run the wrong way. That's just me reading my values wrong. So I actually had that line correct at the beginning. Okay, that's a score. I'm somewhat happy with that. So let's just see what happens with that first. It's right. Cool. Let's keep going. Okay, part 2. This seems like the more interesting bit. Now discard the corrupted lines. The remaining lines are incomplete. Discard the corrupted lines. Cool. So we're gonna just have an array of incomplete lines is going to be an array of strings, I believe. Yep. Yeah, default incomplete equals incomplete. We append to it the current line. Cool. We don't need this, and we will print len incomplete. Cool. I need to do that. So half of my lines are incomplete. Okay. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end. To repair the navigation subsystem, you just need to figure out the sequence of closing characters that completes all the chunks. You can only use those. Like I already kind of know how to do this. Did you know that you can also have autocomplete tools also exist? It's true. Okay, so to complete, so the last completion above will be scored as follows. To start with the total score of 0, multiply the line. Oh. Okay, so there's a bit of an algorithm here. But the long story, the short version is, whatever's left in my stack at the end is going to be, the matching brackets of that is going to be what's needed to complete it, right? So here, I don't want to add the incomplete line. I want to call these the completions, actually. So what I'm going to do is I'm going to save the rest of the stack, the remaining values on the stack, whatever they are. I just need to flip them around. So reverse the whole array and use the closing bracket. But I don't even need to use the closing bracket. I just need to reverse the array. Or technically, I don't even need to reverse the array. A stack here. I'm going to call it string it just to make it a bit easier. So we're just going to take a look at them. Right. Just need to put them on separate lines so we can actually see them. Okay, it doesn't want to do that. That's okay. I mean, you can kind of see, like right here, this is what's needed to complete one of these lines. And to complete that, we just need to follow this algorithm here and use the values for the corresponding closing bracket. So let's read it. Did you know that autocomplete tools also have contests? It's true. The score is determined by considering the completion string character by character. Start with a total score of 0. Start with a total score of 0. I can't call it score because I already have a variable up high called, no I don't, it's, yeah, up high here called score. So I'm going to call this total, which is totally not confusing, of course. /s. Then for each character, multiply the total score by 5. Then increase the total score by the value of the character. So for each completion in my completions, okay, so actually I need to keep track of scores. Cool. So for each completion, I need to loop over each character in the completion. So to do this, start from the end of the line, because we need to do this backwards, and go back to the beginning. We go scores I times equals 5, multiply by 5, then add the corresponding value of whatever it is, which is just this thing again. But this time we're switching comp j, and we're going to use the corresponding open bracket instead. For this, we add 1. For this, we add 2. For this, we add 3. For this, we add 4. There is no default case. Yeah, this should be minus minus. So each one will have these values. The winner is found. Okay. So what we should be able to do here though is print out scores and see what they are. Of course, it's all 0 because we never added them up properly. Okay. So we have the scores of each of our lines. Autocomplete tools are an odd bunch. The winner is found by sorting all the scores and then taking the middle score. Okay, so sort the scores. Sort.scores, it's easy peasy. Now sort.ints, taking the middle score. There will always be an odd number of scores to consider. I have 45, so 45 divided by 2 plus 1. So scores, len scores divided by 2 plus 1 is this value. Let's go for it. Oh, it's not right. Okay, I was a bit too hasty this time. I was trying to be hasty. Maybe my scoring is wrong. But we can check that, I think. I'm going to print scores before I sort it as well, just so that I have something that corresponds to each other. What's a nice one to check? 1, 2, 3, 4, 5, 6, 7, 8. The 8th one is a small relative. No, the 9th one is a small number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is, sorry, I'm counting on my screen. This is the 9th one here. So the closing of this should be 3, so 3, 15, 15 plus, okay, let me just work out the scores. 3, 2, 4, 3, 4, 4, 3. Okay. 3 times 5 plus 2 times 5. Right. 3, 2, 4, 3, 4, 4, 3. 3 times 5 plus 2 times 5 plus 4 times 5 plus 3 times 5 plus 4 times 5 plus 4 times 5 plus 3. Just gotta make sure these brackets are balanced. 5, 6, 1, 2, 3. 5, 6, 1, 2, 3. That's the correct number. So maybe I'm actually just calculating it, doing the wrong lines or something like that. Is this wrong? This is not wrong, right? If I have 3 values, I want the second value. It's 3 over 2, which is 1, integer division, plus 1 is that. Okay, we can do this by hand. I know that there are 45 values in here, right? 45 values, so 23 is my middle one. Whoops. Which is the value I put in, wasn't it? Yeah. Okay, so it's not that. I'm just going to test it on the sample data just to see what happens. Because if I'm getting these wrong, then I'm doing something really wrong somewhere. Whoops. Cool. So we're just going to run it on this instead and see what we get. I am doing it wrong. Of course I'm doing it wrong because I can't do zero-based indexes properly. Oh, what a letdown. Off by 1. Okay. So I had the answer. Yeah, no excuses for that one. That was just me being poor. And if you're wondering why, it's because the 23rd element is, of course, index 22, not index 23, which is what I did there. I think I wasted about 5 minutes towards the end. So let me just check. 5 minutes would have been 15 minutes? Nah, I wouldn't have been that much closer. Wow, people are getting fast at these. Okay, yeah, so I think this was a really cool puzzle. This is a really good way to show how stacks work. And once you understand how stacks work and how you can process these balanced brackets using stacks, it's actually quite a straightforward process. Go doesn't have stacks because why would it? So I used an array and I was just appending to the end of the array and then deleting the final element of the array. And using that as a replacement for a stack. Other than that, I did mess up, yeah, these variables. Maybe if I named my variables better, I wouldn't have had problems. I did call this one pop, and so pop should have been the open bracket. I just didn't connect it in my head. Beyond that, yeah, it was a nice, straightforward, stack-based bracket matching challenge problem. It was cool. I liked it. So tomorrow, yeah, tomorrow should be another stream. I don't see why there wouldn't be. Oh yeah, so there should be a stream tomorrow. There will be a stream tomorrow. It's gonna go up right after this. And have a good morning, afternoon, evening, wherever you are. And I'll see you again tomorrow. Thanks for joining me.